Imagine you were tasked to bring a project from here to a fully fledged game in just 2 months. How would you do it? Hey guys, it's Heap. We were given 7 weeks to go from 0 to here, and this is the second half of our epic journey of Hex Wars. While we were having a little planned break, I couldn't help but wonder the steps needed to go from basic shapes to complex 3D models. We were on a very tight time frame, and we were asked to make a game, not an engine. So I thought of a fairly unconventional idea. Hello. My team has come up with a proposal. Let's just get into it. Here we go. Let's leverage multiple decades of professional industry experience for ourselves and build our development tooling solutions as part of a plugin for Blender. A popular 3D software. Let's build our game assets, game scenes and game models inside Blender and then somehow convert those files into a format our game engine would understand and thus save a bunch of time. Thank you very much, this was my proposal, and if you liked it, the developers kindly asked to overflow the like button, whatever that means. And this is it. Thank you very much for your attention and have a great day. If only there also was an open industry standard format we could leverage that already had integration with Blender. Oh wait, there is. Guys, meet GLTF. It is a format made by Chronos Group for WebGL, but it's entirely open and could be easily integrated into our engine. The final Java implementation was just around 1,000 lines. Also, it was very ugly, so please don't look at it. But it worked. I just wrote a tiny Python script to export the Blender files with correct settings. There are multiple ways you can export GLTF. One of them is an all-in-one binary blob, the other is base64 encoded, and the final one is separate JSON, separate vertex blob, and separate files for individual textures. I chose the last one because the engine already handled textures as separate files, so I didn't want to add extra code on top. The last piece of the puzzle was writing an extension that could allow to add components to game objects. This was by far the trickiest part, as I was slightly puzzled with Blender's Python API, and I also had to parse Java files from within Python. How did I do that? A lot of regular expressions. In hindsight, I think that was my biggest mistake. I should have written the class parser inside Java to make it more robust and work with compiled class files. And that was my plan for the future, but I didn't end up changing it due to time constraints. In the end, we had a relatively intuitive way to set up scenes, networkable objects, and their components all inside Blender. However, we still had to do some parts of our game inside code, because Blender doesn't have a nice way of doing them, for instance UI, that is tricky. But in the end, I think we had a very nice balance of code-based approach and declarative approach. To test things out, I changed the building model and also set up a new main menu with more complex tiles, and it was wonderful. Alright, now let's focus on visuals. At first, I envisioned a very realistic terrain with beautiful water and all that stuff, but we then realized we couldn't quite possibly gather all the textures in time, and it was overall too risky to go for a realistic approach. So, Oscar found a really nice Sketchfab model that had caught my eye, and thus I was all in for a simplistic approach. It was now time to go from here to implement the physically based renderer. I read some papers, looked into a couple of implementations and YouTube videos to gather an idea of how everything works in detail. A very broad overview of physically based renderer can be seen all around you. The driving principle is that everything is physically correct, which leads to objects looking just right in different lighting conditions and across different engines. That part is really cool, not gonna lie. And if you're curious about the nitty-gritty details, don't forget to subscribe not to miss a more in-depth explanation of PBR, coming soon. The process of adding it in was mostly driven by kind of copying reference implementations, and I did get it working, but I wanted to add an extra addition: area lights. You see, by default, all lights are infinitely small points, because the maths are the simplest this way. But our sun is not a point, and I want to have a sun. This led me down a rabbit hole of various experimental attempts to have things look as closely as in Blender. I think my shader can no longer be considered as physically based. I mean, look at this magic. But everything looks fine. And that's what happens when you've got very little time to do for someday. But we now have PBR. With that out of the way, let's see what's changed. Turns out my team's been working on a game, which is really awesome, not gonna lie. It's so relieving not to have to worry about doing everything by yourself. I'm very fortunate. I'm very fortunate. It wasn't incredible progress at that particular time, but we were officially on a break. There were a lot of game mechanics to add, and I ended up focusing on the visual parts. For instance, right here we can see my first documented terrain height test. It ain't much, but it adds a lot. Here's after a few iterations. Yeah, I still needed to add illegal tiles. The rest was a bit of tweaking and bringing tile highlighting to PBR world instead of rendering it as a separate object. This segues perfectly to a topic of material systems and shader reuses. For this to work well, I had to add a small subset of shader pre-processing and reuse the PBR shader. The highlight material and the shader merely adds more stuff on top and reuses the base, standard PBR shader set. And the shader sets in my game engine are bundles of vertex and fragment shaders, as well as properties of render order, transparency, and all the stuff the renderer needs to consider before rendering. Investing in a good material system was very worthwhile. It was advice Coin gave me, and I'm glad I took it. The end result is the exact same PBR with a color overlay on top, which looks very tasty, not gonna lie. I then added Fog of War feature, not gonna lie, it had a lot of iterations along the way. This here was purely client-sided, but my hope was to eventually make it server-sided. Then I had a bit of a fight with transparency. How did I solve it? With the use of an amazing tool called RenderDoc. It's beautiful. It allows you to capture and analyze individual frames at per pixel level, per shader. It's amazing. It's a must if you're making graphics. Turns out, I was doing sorting based on object origin in hierarchy, without considering the mesh origin. A simple fix of calculating AABB bounds of the mesh and offsetting the origin helped me solve the issue. I then changed the tile highlighting effect to be less pronounced in the center, because a friend of mine suggested it was rather confusing to know where was ground, where was water, where was enemy territory. Now, it was brought to my attention that the UI transforms I wrote were completely broken. So here I spent the next day and a half fixing that. I finally got around to adding map synchronization and only revealing it to the player when they're able to see that part of the map. It's a key security measure, and I wish I could extend it to the rest of the game to make it a full occlusion system for network sync, but you already know the drill. After a few iterations, we ended up with something that I think is rather beautiful.
But what the fuck, kas čia vyksta? Bruh, this main menu. What is going on? What is wrong with you? Why you so fast? Why you so fast? Kas čia buvo per eroras? No such field exception, wobble range, wobble range. What?
We're nearing an end. Most of the game features are done. It's now time to sprinkle some finishing touches into the mix. I create a few house models in Blender that differ slightly based on stats. Another teammates make gameplay more intuitive. I added visual arcs for when you attack, mess something up right here, don't ask. And then add fireballs for when an attack happens. I create a few final models. One for the capital, and also some props. A dynamic blacksmith for production, different walls for defense, and war carts for attack. Along the way, I also did quite a few under the hood changes, like making the networking more robust, and doubling the frame rate through some engine optimizations. But the final thing we added was a day and a night cycle. I found this article on light temperature, made it look very nice, and so we have a game. We did a little playtesting, added a few game mechanic tweaks, and it was absolutely beautiful. The last thing we do is create a presentation and present it. Oof! This was a trip, with a very satisfying end result. I skipped quite a lot of game design, not gonna lie, because I wasn't that involved with it. The rest of the team did a wonderful job, huge props to them. Like, I couldn't have done this by myself. We split all the work equally on the submission, and we got 90%, which is pretty unreal. And yeah, I'm very satisfied with end result. And when things calm down, I hope to do more game development from scratch. Hopefully in Rust this time around. But yeah, if this was awesome, then overflow the like button to help me reach -2 billion likes. And also, the code for this whole project is in the description. It's public, feel free to check it out, dissect it, just don't look at any of the Java code. but yeah, and don't forget, my name was Heap. Yours was undefined. See ya.